All right, guys, video number 2 in less than 10 minutes. Wow, moving quicker now. Things are working like they're supposed to, so here we go. All right, so hey, I'm in the same outfit. I'm doing 2 videos in a day. You get a bonus package. So we talked about on the last one that we were talking about how the derivative is the slope at any point of f of x, and we can use that, remember, to find the tangent line, just real quick. Okay, so we could use that to find the tangent line. And then you guys were taught the limit definition, which we really don't have to, we need to know, but we don't use it all the time. And then we have what's called the power rule, which was multiply your power to the front, to the coefficient, subtract the power by 1 on anything that is in like a standard polynomial form. And that's how we got our stuff on the worksheets for the tangent line and the normal line. So all fine and dandy when everything looks pretty, like, you know, I think the one we did was like 3x squared minus 5x plus 8 or something like that. So when they're nice like that, or the square roots, or, you know, x to the 3 halves, everything's great. But then they go ahead and say, oh, well, f of x is this ugly looking thing, x squared minus 5 to the 8th power. So then you got to ask yourself, who wants to do this algebra? X squared minus 8 multiplied by itself 8 times to turn it into kind of a standard looking polynomial that's got all the powers in a nice row like we have been. You can do that if you want, and we'll see it, you know, in a couple of weeks when you actually get the right answer. It gets a little ugly after a while. So, since the power rule is more of a theoretical shortcut to the limit, the definition of a derivative using limits, then this next thing I'm going to teach you guys, which is called the chain rule, is a shortcut for the power rule when it gets big and ugly like this. Let's slide over to the power rule. On your worksheet, it says the package rule. If I can erase it, I will. There's a set of directions for the package rule. I really don't call it the package rule. Never really found it anywhere. So it's called the chain rule everywhere. Okay, so I'm going to teach you a little different way than what the worksheet shows you. I like this way because we're going to use what's called U substitution. And U substitution comes back when we do our antiderivatives in our next unit and stuff like that. So let's take this ugly one that we talked about right here. So we know that f of x equals x squared, the quantity x squared minus 5 in parentheses to the 8th power. Now, that poses a few problems. So this is I'm going to erase the package rule because I'm going to keep saying it. I just did that because that's what it says at the top of your worksheet. So we got the chain rule. So the chain rule is this. It's just like the power rule except one extra step. We're going to take the derivative of, and I'm going to put parentheses right here. I like parentheses better right here. We got our parentheses, and that was A. So we have the coefficient out front. We do the same like we did. We multiply to the front, and we subtract by 1. So we really take the derivative of the whole thing. And then from there, we take the derivative of the inside, whatever's on the inside, regardless of what's on the outside. Okay? So that can get a little confusing at times. So now I'm going to tell you, or show you, some things that you've seen algebraically, but you didn't know what they were used for. And that's substituting or changing the rules to make your equation easier. So let's check this out. All right, so we've got this f of x equals x minus 5 to the 8th power. Now, what I decided to do is over here, I just say, all right, let u equal x squared minus 5. U is going to equal x squared minus 5. And with that, I go, okay, I'm going to change what f of x looks like. So f of x is actually u to the 8th power, because I just substituted what I told it to equal. U equals x squared minus 5. That's what we mean by U substitution. We're using the letter U to interchange things. So now what does that do for us? Well, it allows us to do a couple of different things. So if I cover this up, you guys don't look at this, U to the 8th, I can do the power rule too. I can multiply to the coefficient and I can subtract 1. So what we do when we find the derivative is we do our power rule to the whole thing. 8 times 1 is 8. 8 minus 1. Okay, that's the power rule. Here's our next step that we got to remember to do. We have to take the derivative of the inside. What's the derivative of the inside? Well, if f is f prime, then u will be u prime. So take the derivative of u prime. 2 times 1 is 2. 2 minus 1 is x. Now, it's a constant. When we take the derivative of the constant, that disappears, and so all I'm left with is u prime is equal to 2x. Well, if I have to take the derivative of the inside, that means u prime is on the outside. So remember, derivative of the whole thing, using the power rule, times the derivative of what's on the inside. Well, on the inside it's u, so I got to take the u prime derivative here. So now I've got everything set up. All I have to do is resubstitute using u substitution. What is u equal to? U is equal to x squared minus 5. What is u prime equal to? 2x. It's right here. And then I just kind of clean everything up. 2 times 8 is 16. X moves out front. 16x to the times the quantity x squared minus 5 to the 7th power is my derivative of this thing without multiplying it all the way out using u substitution. So we substitute u, we find the derivative. Also, guys, this is also known as du. So you could also see it written as du equals 2x. Okay? They mean the same thing, and we'll deal with that later. But that's the idea. So, now what are we saying? Oh, these little dots here, these mean therefore. Therefore, f of x is now this because of u substitution. And so once we find this, what are we saying? I'm going to keep saying this so you guys kind of get it in your head. Therefore, the slope at any point on the original f of x to the quantity x squared minus 5 to the 8th power is f prime, which is now 16x to the quantity x squared minus 5 to the 7th power. That is the chain rule. Shortest version of the chain rule. Derivative of the whole thing using the power rule times the derivative of the inside using u substitution. All right, guys, good luck on that, and we'll talk about this tomorrow. Chain rule. Coming around, takes me a while, getting there, and it's off.